All right, so we are going to finish up lesson 6.4 today. Let me show my screen. All right, so for day 2, we're going to look at the transformed log graphs and writing log rules. Okay, so again, you have your notes here on the different transformation rules, which again should look very familiar to all of our other transformation rules. And you can see examples here. So this is an example of 4 units to the right, 7 units to the left, 3 units up, 1 unit down. So in parentheses, outside parentheses. Changing the sign of the x reflects over the y. Changing the sign of the y reflects over the x. Horizontal shrink of 1/4. Horizontal stretch of 3. Vertical stretch of 5. Vertical shrink of 2/3. Okay. So just like I did, I'll graph this first one, but then I'm just going to go through the transformations and you guys will graph the rest on your own. Okay. So for the first graph, talking about the transformations first. Oop, ignore that scratch. Okay, so we have the negative inside the parentheses with the x. That's changing the signs of all the x's. So that means it's a reflection over the y-axis. Reflect over y-axis. And then the 1/4 inside the parentheses with the x. That means there's a horizontal stretch by 4. Horizontal stretch by 4. Okay. Now, in order to graph, I'm going to first graph the parent function and then perform the transformation. You can graph both of them on the calculator and then just grab the table of values. All right. If you weren't using, maybe this one I won't use a graphing calculator, just to show you an example. If I was not using a graphing calculator, I would actually change this to expo form. All right. In expo form, this is the same thing as 10 to the y equals x. Okay, so 10 to the y equals x. Typically, I would say pick values for your x, and then, figure out what y is. But since it would actually be easier to pick numbers for y, so I'll just pick -1, 0, and 1, right? 10 to -1 is 1/10. 10 to the 0 is 1. 10 to the 1 is 10. It's a lot easier to pick values for y and then solve for x in this case. So for the f of x function, I'm going to plot -1 1/10, so super close to the x-axis, and then 1 0, and then 10 1. So over 10. Did I do this? Oh, I'm sorry. Let me start over. I don't know why I was going negative. Sorry. Positive 1/10, -1. I don't know what I was thinking in my head. Positive 1/10. So you're just going over a teeny bit and then down 1. I don't know what I was doing when I was graphing before. All right. Positive 1 0. And then 10 1 would be like somewhere out here. Okay. So this has an asymptote along the y-axis. Oop. And it looks like that. All right. Now, if I wanted to graph the new function, all right, I could perform the transformations. I could change forms. Let me erase all this for a second. For the g of x function, I could change forms. So changing forms, it would be base 10 of y equals -1/4 of x. Multiply both sides by -4. So then you'd have x is equal to -4 10 to the y, right? So just like I did before, you could pick values for y and then substitute them in and figure out the x. So for instance, if I pick 0, 10 to the 0 is just a 1. 1 times -4 is -4. If I plug in a 1, 10 to the -1 is 10 to the -1 is 1/10. And then 1/10 times -4 is -4/10. Or you could simplify that to -2/5. -2/5. Okay. All right, so then I could plot those points, -4, 0, and then -2/5, -1. It's about right here somewhere. Come on. Come on. There we go. All right, so here would be your g of x function. So this one's g of x, and this one was f of x. Okay, so you don't have to use a graphing calculator for the logarithmic functions. You can change forms and then figure it out by hand as well. All right, let's go to the next one. All right, for this one, I will do it on the graphing calculator just to show you the option that I'm sure many of you are going to take anyway. All right, so for the transformation, I have my 3 and I have my -2. So this is a vertical stretch by 3, and this is a translation 2 units right. All right, so for this one, I said I'd do in the graphing calculator. So go to y equals, I'm going to clear out the functions that I have. So for the first function, it's log base 1/3. So 1 alpha y equals third. Oh, of x. And the second function is 3, and then log base 1/3 of x minus 2. And then I can graph. Okay, so to figure out how to graph these or what points to use, you can just hit second table and list. Remember, the arrow just means it's the asymptote, right? It continues to go on and on forever, but it's getting so close and doesn't actually cross over. Okay, so there is an asymptote. But you can just grab some of these points to help you graph. Okay. The other option, if you didn't want to use your graphing calculator, I would change this, right? It would be 1/3 raised to the y equals x. And for this one, oops, if I was making my x and y table, I would again choose points for y. It's a lot easier to plug in for y. So I would choose like -1, 0, and +1. Okay. And then evaluate there. All right. And then for the g of x function, same thing. I would change it into 1/3. Oh, actually, this one's a little more challenging. Let's see. So we'd actually have to condense this one a little bit in order to change forms, which we haven't learned yet. So for this one, trying to think. Actually, okay, let me do it this way. Y equals 3 log base 1/3. All right, so before changing forms, I would divide both sides by the 3 out front. Dividing by 3 is the same thing as multiplying by 1/3. So 1/3 of y equals log base 1/3 of x minus 2. All right, now I would rewrite it as the base of 1/3 raised to the 1/3 y equals x minus 2. Okay, so I would change forms at this point where I have my base, bacon, and eggs. So I changed it to the base, the 1/3, raised to the exponent, which was 1/3 y equals the answer, x minus 2. And then you can even do one step further, add 2 to both sides. So you'd be left with 1/3 raised to the 1/3 y plus 2 equals x. And for this example, again, it would probably make most sense to pick numbers for y. So you pick a 0 and like a -3 would probably be the easiest too. Oh, I didn't mean to erase it all. Sorry. Let's do that again. 1/3 raised to the 1/3 y plus 2 equals x. So pick numbers for y. I again would pick 0 and -3. Okay, when you plug in the 0, 1/3 times 0 is 0. 1/3 to the 0 is 1. 1 plus 2 gives you a 3. Okay, plug in a -3. 1/3 times -3 is -1. 1/3 to -1 is a 3. 3 plus 2 is a 5. Okay, now that's a little more advanced. If you want to just plug that into a calculator, you can do that as well. All right. Okay, the next one, it says write the log rule. Okay, which we've done these before as well in all of our other chapters. Let the graph of g of x be a reflection in the x-axis. Let's start with that. Move this up just a little bit. So reflection in the x-axis means the y is changing sign, so the negative goes out front, -3 to the x. That's a reflection in the x-axis. Translation 2 units to the left. So 2 units to the left means that up in the exponent, you're going to have an x plus 2. All right, and I believe that is it. Yep, so you have g of x, oops, I forgot an equal sign, equals -3 to the x plus 2. All right. And number 4, the last one, let the graph of g be a translation 1 unit down. Okay, so let's do that first. 1 unit down. So that means for g of x, it's going to equal log base 1/6 of x. And then 1 unit down, that means on the tail end, -1. All right. Then it says a vertical stretch by a factor of 5. So that 5 is going to go out in front. So you're going to have a 5 out in front, log base 1/6 of x minus 5. Okay, you could distribute that 5 or you could leave it like that either way. If you wanted to distribute the 5, you would have g of x equals 5 log base 1/6 of x minus 5, right? You would distribute the 5 here and there, and that would be your final answer. Or like I said, you could leave it without distributing the 5. That would be fine as well. Okay. All right, guys, that is it for lesson 6.4, day 1 and day 2. So I will see you back here for lesson 6.5. Bye.